You are, of course, familiar with the way of creating a square symmetric matrix from a non-symmetric matrix through the multiplication method. So that is, you take any matrix, multiply it by its transpose, and the product, so A transpose A or A times A transpose, that product matrix is guaranteed to be square and it's guaranteed to be symmetric. It also has many other nice properties that you will learn about later on in this book. For example, its relation to eigenvalues and eigenvectors and singular value decomposition and so on. Here in exercise 9, we are going to explore a different method for making a symmetric matrix from a non-symmetric matrix. Now, this additive method is not as useful, it's not as practical as the multiplication method for a variety of reasons. One of which is it only works for square matrix. It doesn't work for non-square matrix. It's also not guaranteed to have a bunch of these really nice properties that the multiplicative method has, but still, it's an interesting exercise to work through this additive method. Okay, so the method is really simple. All you have to do is take a square matrix, transpose it, and add the matrix to its transpose. And then I say average, so you want to divide the result by 2. So matrix A plus matrix A transpose, and then divide by 2 or scalar multiply by 1/2. Okay, so implement this algorithm in Python and confirm that the result is symmetric using the function that you wrote in the previous exercise. Well, this one is pretty straightforward. So here I generate a random matrix that's square. I add it to its transpose and then divide by 2. And then we will see, I expect the output here to be false, true, because A is not a symmetric matrix, so that's false. A transpose A, which is actually A plus A transpose, I expect that to be symmetric, so that should be true. Okay, now I just want to say one quick word about why you want to divide by 2. It is actually not necessary for the symmetry to divide by 2. So here we see matrix A, and then I'm going to print out A, and here I'm going to print out A plus A transpose. Okay, and then let me just add in a space in here. Okay, so here you see matrix A, and here is A plus A transpose. Now you can just quickly confirm that this matrix is indeed symmetric. You see all the corresponding elements off the diagonal are the same. Now, when you look at the diagonal elements, you can see that they're larger here than they are here. In fact, they are double. So, this is 0.57 and this is 1.15. This is 1.26 and this is 2.52. So this matrix is like twice as big as it should be. And that is the reason why it's convenient to average them. So now I will average this result. And now you can see it's still symmetric and the diagonal is preserved. So the diagonal elements of the symmetric matrix are identical to the diagonal elements of the original matrix.